So I was part of the research experience for high school teachers in sustainable transportation technology, along with my partner, and our topic was bioengineering trees for better biofuels, and we got the chance to work in a biotechnology lab here at Michigan Tech, where we got to learn how they are transforming plants in order to put a gene in that will make them a better source for biofuels. And so these are the different techniques that we learned in the lab during our 6 weeks here. And basically we learned to construct a gene of interest, which would actually make the lignin in the tree be decreased in order to increase the amount of cellulose. And we were able to clone that gene of interest into the bacteria by using a heat shot method. We isolated the plasmid DNA, so we got our gene of interest all by itself. We then had to put our plasmid into an agrobacterium, and this agrobacterium is able to actually infect the plant that we want to transform. It has transfer DNA, and we're able to use that. Once we've got our gene of interest into the agrobacterium, we're going to see undifferentiated growth. We get a callus. We're going to make that callus shoot and then eventually root. And what you end up with is, this is the greenhouse here at Michigan Tech, and those are transgenic aspens. They have this gene of interest in them, and if we were to test them, we would expect them, in this case, based on this study, to have that decreased amount of lignin. This was all based on a research study done by Hugh et al. These are their conclusions that they had, and they found up to a 45% decrease in lignin in the transgenic lines of aspens as compared to the control line of aspens. Those that were not genetically modified were not bioengineered.